Welcome all to this new session, Simplification of Context-Free Grammar. Myself Dr. Sunitha from KL University. So the aim of the session, aim of studying the simplification of context-free language is to understand and apply techniques to simplify the context-free grammars. The instructional objectives are this and the learning outcomes are these. So in the simplification, first we should know the substitution rule. If this is the production rule, we have to substitute for B, and how we substitute for B is like this. The equivalent grammar is like this. Wherever we find this capital B, we'll substitute additionally. Okay, the existing grammar will be there. In addition to that, we will add one more production by substituting small b for the capital B. So this is the base that is helpful when we do the simplification of the grammar. Another example is like this, BAA, substitute AA like this. Okay, so existing productions we have to keep there. In addition to that, we have to create new productions by substituting AA instead of B. Okay, so this will be replaced, will be like this. Okay, then A gives X, B, Z, B gives Y1, substitute B gives Y1 here. So it will be like this, AX, BZ and AX, X, Y1, Z. That will be the equivalent grammar. Then what is nullable variables means if any production end in epsilon. Okay, A gives epsilon, A gives lambda is an epsilon production, or if we, so A is a nullable variable, and if we start deriving from A and we end up in epsilon, after the end of the derivation, multiple derivations we do, and at the end if we reach the epsilon, then it is then also A is called a nullable variable. Okay, removing, how we remove the nullable variables from our grammar. So for example, if we have a grammar S gives A, M, B, and M gives A, M, B, M gives epsilon. Okay, so M is a nullable variable. So what we have to do, we have to remove this production from our grammar. That means M has to be replaced with the epsilon in that case. So we have cut down this grammar and we have to modify the existing two productions. So S gives AMB is there, S gives AB. How this comes means instead of this AM we substitute epsilon. So it will become AB. So we got another production. Then we have M gives AMB. So here also we have to substitute epsilon for AM. Okay, so we will get M gives EAB. That is how we remove the epsilon productions. Then unit productions. How unit production is means on the right hand side we have a single variable, not terminal, it is a variable. So A gives B. In this format, if you have any production, those are called the unit productions, a single variable on the right hand side. So A gives A can be removed immediately. Same way production gives. So this is meaningless. A is replaced with A does not give any meaning. Then consider an example. S gives A gives A gives B, B gives A, B gives BB. This is the production. So let us find out which are the unit productions. So this A gives A is not a unit production because on the right side we have a terminal. So it's not a unit production. Then here we have A gives B. A gives B is a unit production because B is a single variable. Then B gives A is there, that is also a unit production because A is a variable. So there are two unit productions here. Now how we remove this unit production? So we change A gives B, A gives B we remove, instead of that we will add B gives A, B. Okay, so that means for one production this B gives A is there, and what is A? A was A is B. Okay, so it will be in cut short, it will be written like B gives B, and B gives A is already there, so this will be added. A gives. So that is the thing, that is how we have to remove this. Then B gives B is meaningless, so we will remove B gives B. So finally it is B gives A. B gives A remains there. So this is the production. Then B gives A is a unit production, that we have to remove. And B gives A means B gives A. Then what is A? A is A, small a. So we can, instead of B gives A, we will write B gives small a. Okay. B gives B, we cut B gives small a is there. Okay. Substitute B gives A, so B gives it has to be like this. B have to be B gives A. Okay, that is the substitution we are doing here. Then the final grammar is like this. Okay. Then the useless productions and symbols. Finally, we have to remove the useless productions and symbols. So that means useless production means that productions which do not contribute to the derivation of the string, that are the useless productions. And useless symbols means the symbols that are not reachable from the start symbol. So this is the production. S gives A as B, S gives lambda, S gives A gives A. Okay, then some derivations never terminate, those are the useless productions. Okay, so like this, A gives A, this is a useless production. So we remove that one. Okay, there's another grammar is S gives A gives A gives lambda, B gives BA. Okay, so this is the useless production, not reachable from S. So from S we can reach A, from A there is no way to reach B. Okay, so this is a useless production. Then if in general, if S gives S, from S we can derive any string W, then A is a useful symbol or a useful variable, otherwise it is a useless variable. Then if a production A gives X is useless if any of its variable is useless. Okay. A of X is useless if any of the variable in this X is useless. So the variables A, B, C are useless. One thing is from this we cannot produce any productions. From these we cannot produce any production. And B and C are not reachable from this S. So they are useless productions, useless symbols. Okay. So removing useless productions from this grammar. S gives AS or A or C, A gives A, B gives A, C gives A, C, B. Okay, find all the variables that can produce strings with only terminals. So we'll check with all the productions. These are directly producing, so no issue. Then we have to check with the S gives A, S gives A, B. Okay. So we keep only the variables that produce terminal symbols A, B and AS. The rest variables are useless. So we find that C is useless because this production cannot derive any strings. So that is when we derive from from S we start deriving, substitute it with C using the production, and this C we have A, C, B like this. So again this C can be replaced with A, C, B only. So it never ends, it will go on. So this production S gives C is useless, and when we remove this production from our grammar, C becomes unreachable. So C gives A, C, B is also a useless production here. Okay. So we have to remove those useless productions and symbols, and the remaining will be like this. S gives A, S, A, or A gives A, B gives A. Then find all variables reachable from S. So from this A can be reached. Okay, from S we can reach S and A, and there is no way to reach B. Okay, so there is no way to reach B. So that means B is an unreachable variable. So he says useless variable. B cannot contribute to the derivation of any string. So it is useless. Keep only variables reachable from S. Okay, so this is the remaining grammars. Okay, so this is another example. S gives. So in short, one thing I have to say, how to simplify simplifying the grammar, simplify CFG. You have to first remove the null epsilon productions. Okay, so first we have to remove epsilon production. Epsilon or lambda, both symbol we use. Okay, then we have to remove unit symbols, unit productions. Okay, then finally we have to remove useless productions and useless productions and useless symbols. So we have to do in this particular order. First we have to remove epsilon production, then unit production, then useless production. That is important. Then removing useless productions for this example. This is an example for removing. So first useless production means you check with S gives AC. A can be replaced with a small letter A, C can be replaced with small letter C. So S gives AC can generate some output, at least this string it can generate. Okay. Then we check S gives B. What happens? S gives B means there is no production given for B. Okay, so that we can cut. Okay, so that we can cut here. There is nothing given. So S gives AC, and E is not reachable from here, and this is also not there. So only the remaining thing will be AC, and A gives A, and C gives small letter C. That is the only remaining production. This production is not there. It is not given. We have any production kind, B gives this. So this is the simplified one. Okay, it is removing useless symbol. Okay, so these are the steps to simplify any production. Remove nullable variables, that is remove epsilon productions, remove unit productions, remove useless productions and symbols or useless variables. Okay, so consider the following grammar. S gives A S1B, S1 gives A S1B slash or lambda or epsilon. Okay, so after removing these this is another problem. Okay, show that the grammars are equal, and these are some of the example questions we have. Okay, so here let us take this example. S gives EAA. Here we have to remove all the unit production. The unit production here is, this is the only unit production. A gives B is the unit production we have. So we have to let us check what is B gives. Okay, so what is the production for B? B gives A B, B or BB. Okay, so what we have to do? We have to replace the production of A like this. A B B or B or BB, like this. Okay, so the production, the answer will be like this. S gives AA, that is not a unit production. This one will be A gives BB is there. Then this remaining part we have to take, instead of A gives B, we have to write A B B and B or BB like this. Okay, and what is B? B is this, A B B and B and BB like this. Okay, this is the productions after removing the unit production. Okay, that is all about the simplification of CFG. So this is the step we have to follow: remove null-level variable, you remove unit productions, you remove useless productions. Okay, so thank you all for your patient listening. Thank you.